let's see if there's anything I want to talk about here. So the term scope refers to the visibility of a variable, okay, or a function in this case, or pretty much anything, or piece of code. And in Java, you have, we talked about the global scope, right? Global variables and global scope. We talked about local variables, so they have local scope. Okay, local variables are always contained within a function or method. And then inside a function or method, you can have block scope. So a block will be something like this. You see a pair of curly braces. Suddenly here you have two of them. Okay, so you have two block scope variables. And because they're contained within the block, you can see that you can declare two same variable names inside the method two declarations, right? Because they are contained within each block, they're completely independent, and so the data doesn't leak out, and so therefore they're allowed. If you don't put the curly braces here, then therefore you're not allowed to create the same variable twice, right? Because it's already duplicated. So that's a block scope, and then any variables you declare inside the block scope is called to have a block scope level. Okay, so that. Let's see. The term shadowing here, it just means that you're able to have the same variable names, but they're in different scope. Right, so the example it gives here is a global variable called like emp num for employee. I think it's an employee number. Again, this is in the outside space of a function, so this is a global variable. But if you look inside this function method that uses local variables, there's another variable called the same name, int num, right? So this is completely allowed because this variable inside here is local and this is global. And so the term shadowing means like this local variable is actually shadowing the global variable, because when you reference the emp number down here inside the local variable, you're actually using the local variable value here and not the one in the global. So in that case, it's like shadowing each other. Okay? So that's what that term means.
And that's one that supersedes the local.
Yeah, right. So the local will always supersedes or have a higher precedence over the global. And if you want to access the global variable, remember you have to use the keyword this, right? This dot the global variable, then you can access that global variable. Okay. If there's a a conflict with the local variable, in this case like the emp num, because this is local, if you just say emp num like here, then this will always referencing the local variable. If you want to access the global variable out here, then you have to put this dot emp num here. Okay, so that is the difference, I guess, to get out of that shadowing phenomenon. Okay, so overrides. We did this last week. No, we did not. We did overload last week. I'm gonna review this overrides later on. This one here is a little bit, the term overrides used in this context is a little bit confusing, because usually when we talk about the word override, is usually always refer to functions and not variables. Okay, so in this case, it's saying that you can have the same variable in two places or multiple places as long as they're contained within a different scope, right? So that's what it is. But really, the term override you hear later on in object-oriented context is always referred to a child class overriding a parent's class function. Okay, so we'll revisit this again later in chapter 10. So here we talked about this 2 weeks ago about overloading a method, right? That means you can have the same function as many times as you want in the same class. So the overload here is always in the same class only. So you have the same function name as long as you have what's it called, a different signature. So the word signature here, it means the parameters inside the parentheses of the function head here. Okay, so I can have like um, in this example I have here, I have like two functions. One is the display, has no parameter, and the second is the same name but has one parameter, right? So because that signature is different, so that they are unique, and so therefore you can have two or more functions of the same name and the same class, and that term is called overloading because you're overloading a function or a method. Okay.
So for the display, is it a function because it was called?
Yeah, right. Display is a function. So you declare a function here. It has the void type, right? And then you declare it again here. Same thing, but this one has no parameter. This one has one variable, one parameter. Okay.
What's the difference between that?
Did
The
you,
double A there. What do you call it? You call it that function there?
are you saying like when do you call the function?
Like you have display of the unit, right? You have display with double A.
Mm-hmm.
So then
Yeah. So when you call the function display, you can choose whether to call this one with a no parameter, or you can call this one with one parameter. Okay, so if you call this one with no parameter, then you can call it any way you want, right? Just don't pass any data to it. If you want to use the other one instead, then you have to pass the parameter to match that. So they tend to match. Okay. And this is also, I think I demonstrated this last time using the constructor, right? We did like two different constructors. Yeah, so it's the same idea. Usually this feature is very easy to understand and do in Java and C++ and C Sharp. I would say on those strictly typed languages, but this is not very useful in PHP and JavaScript or any loosely typed languages because they don't care about the data type. So therefore, I can use a double, a string or integer, doesn't matter, and therefore it's really hard to have a very unique function because they don't care about the data types, right? So that's hard. But in Java, it's very sensitive to that, so it gives you that flexibility of creating as almost like an unlimited number of functions if you want to. So that's called the overloading a method, or sometimes just call it method overload or constructor overload. So we have the term overload. It's always referred to a function having the same name inside the same class. I know it's gonna takes a while to grasp that, but as you do more of this practice, you'll get used to it. Okay, so that's that. And here's a list of the two different types. Again, this part here on the overriding methods here, we'll do this in chapter 10 when we talk about inheritance, because it has to do with two classes. Okay, so overriding does not occur in a single class. It has to be between two classes, and overloading is only in the same class. Okay, so similar ideas, but different between different classes. So again, here, so you have like three functions, one with no parameter, with one parameter, but it's a string type. This also has one parameter, but it's an integer type. So therefore, they are unique, and they're the same class called pet. Okay, just to give you a quick peek of what's like over here. Similar idea. As you can see, this one here, the pet has two functions. So these two are, in this case, in this class, is called overloading methods, right? Because this is the same as this over here. But we have another class called dog, and the word extends the pet means this pet class is called the parent class, and then the dog class is the child class of the parent. So in this case, as you can see, instead of the dog class, you have the two same functions again, speak and speak again, just exactly like parent. So in this case, two classes that are sharing the same functions, in this case, is called the overriding methods. Okay, because the child class is, overriding the parent's functions. Okay, similar to the concept we talked about earlier about the shadowing. Okay, so you have the global and the local, right? So this is like the global, and this is like the local. Okay, so that's again that's overriding. So we'll revisit that again in chapter 10. Okay, so I'll go here. We did this constructor overload last time. This keyword here, this reference always refers to the current class. So whatever that class is being used, I mean wherever this keyword is used in that class is always referred to the class or the object of that class. And this is just a different technique here. I'm not going to go over that. Yeah, we'll revisit this again, and this actually become very important when you have two or more variables. So here is a I guess it's a more complete a diagram of these types of relationships between classes. Okay, so we talked about composition, and then there's an aggregation, and there's an association, right? And if you read about these here, kind of put the notes in here. So we have aggregation, and then composition is these keywords here, has a, and the part of, and there's another one called is a, which is not down here, is a. Okay, so it's if you think about this, sometimes you'll see that the word aggregation and composition are being used interchangeably to mean the same thing. Because I mentioned earlier in the diagram, we said that, the school has a student, right? School has a faculty. So if you look at the notes, you can say has a faculty, right? So it has that kind of relationship. But to be more specific, composition is thought of to have what's called a part of something, like part of the engine, right? So like my arm is part of my body, right? It is so. But if you think about this aggregation, I also have an arm, right? So in that kind of relationship. And then when we talk about later on, there's another one called is a relationship, and this is the inheritance part when you have a parent-child, right? So the parent has a child, but then the child is a child of a parent. So those kind of relationship. And if you are if you have experience using databases, it's the same idea, same concept. In that situation, we have those relationships. All right, so I think that's more about nested classes. You can nest class inside another class, and not recommended, but you can. We're not going to do that in this class, but just so that you can. If you see it, you may wonder why, but you can. The only thing you cannot nest inside another is functions. You cannot put a function inside another function, but you can do class. Okay, so that is that. So here again is that is a type and the has a or part of type of relationships. So if you were to think about these objects, because again, object Java is object, right? So if you think about the heart by itself, it cannot survive, right? So therefore, it has to be a part of something. Okay, that's why they have these term part of. And a person has a heart, right? And this person here is an organism or living organism in that case. So I mean, they use those terms to make you have a better understanding of the relationships between classes. So when you write your classes in your program, you kind of think in this term. So we have, let's just say, you write a program about, let's just say, I don't know, a school, right? So the school is a class. What does school have, right? Schools have faculty, they have the students. So students and faculty are two completely independent classes. And then if you go deeper into the faculty, what do they have, and then what is something that is a part of those classes. So when you design your programs, you think about these objects, and then you would create classes out of them, so you know where and how they are related.